In this video, we're going to learn how to evaluate inverse sine, cosine, and tangent. I'm going to give you like a brief introduction for each one. Okay. For sine, if you remember, and before I start, you need like a strong knowledge on how the normal functions like sine, cosine, and tangent, how they work, right? Because if you don't know how to evaluate sine of 90 degrees or sine of 3 pi over 2 or 3 pi over 4 or whatever, you're going to struggle to understand how to deal with this. Okay, so let's talk about the inverse sine first. And to talk about this, we need to talk about sine. So let's suppose that we have the graph of sine. Okay, so if we have the graph of sine, here we have pi over 2, we have pi, 3 pi over 2, 2 pi, maybe back here we have negative pi over 2, whatnot, and we have 1 and negative 1. You probably know that the graph of sine is something like this, right? Well, let me try to do it a little bit better, like that, like so. All right. Okay, and we know that this repeats, right? So this is negative pi, and I know, and you know that this is going to go up and whatever. All right, that it's going to repeat itself because it's a circular function. Okay, so this keeps going. That's what I'm saying. Okay, so for sine, and if you remember the inverse functions from your study of functions, you know that the function needs to be a one-to-one function. That means if you apply something that is called the horizontal line test, is that if you draw a horizontal line and the line touches in 2 points, the function is not one-to-one. That means that the function for two different values, the function has the same output for those two different inputs. Okay, so now what we're going to do here, it's restrain the function to be able to make a one-to-one. The one-to-one functions are the one that has inverse functions. Okay, and to be able to do that, what we're going to do is just restrain the function for sine from here to here. That means from negative pi over 2 till pi over 2, right? So if we erase all this, and let me erase all that, okay, here is 3 pi over 2, and here will be, okay. If we restrain the function there, no matter how many horizontal line tests you make, they will never touch 2 points. So that means that the function, the sine function, restraining the domain from negative pi over 2, right, till pi over 2, it's a one-to-one function. That means that I can come up with a new function that is going to be the inverse sine function. And we're going to represent that with this symbol, sine minus 1, that you will read inverse sine function of x. Okay, or you can do it as arc sine. Both things represent the same thing. It's two different notations to represent the same thing. All right. So how are we going to define the sine function after we do all this? Okay. So the idea is this: the inverse function, the inverse sine function, is going to be defined as y. Y. It's equal to sine, the inverse sine, and we're going to use that negative 1 as a power, but it's not a power. The inverse sine of x, if and only if x is going to be equal to sine of y. Okay, and we're going to restrict the domain and range. So the domain, or the value for x here, must be from negative 1 till 1, and the value for y is going to be from negative pi over 2, as I showed you in the graph a couple seconds ago, till pi over 2, right? So we're restraining the domain and the range for the function. Maybe this doesn't make any sense, but let's see it with an example, and I bet it's going to help you identify how to deal with this. Okay, so let me erase this. Oh, actually, let's evaluate inverse sine of 1 over 2. Okay, 1 over 2. How can we deal with this? What this is telling me is, hey, if I think on the sine function, right, sine of an angle, it's equal to 1 over 2. So what this basically is an angle. I'm looking for an angle in radians, right? In radians, in which I get 1 over 2. Okay, so I'm looking for this angle here, this one. Okay, I'm just rewriting my inverse function to think how to get back. Okay, so so the idea now, it's okay, which angle is that? If we go to trigonometric ratios and if we go back, we know that there is a triangle, right? The 60, 30, 90 triangle that relates 1, 2, and the square root of 3. Okay, and if you think about it, sine, it's basically opposite over hypotenuse. So I can think, all right, which angle relates 1 as the opposite and 2 as the hypotenuse? And you can see right here that angle, it's 30 degrees, right? 30 degrees. If you evaluate sine of 30 degrees in this triangle, you get opposite, that is 1, over hypotenuse, that is 2. Oh, okay. So if I think about it, my angle, or the angle that works here, is 30 degrees. But if I go back here, okay, I know that I'm looking for that angle, and that angle is 30 degrees, and I'm looking for that angle as a radian. So 30 degrees as a radian is going to be pi over 6, right? So that will be the angle or the solution, okay, for the inverse sine of 1 over 2. Okay, so let's do a couple more examples and see how this goes. Let me leave the definition. Okay, so now let's evaluate inverse sine of, I don't know, 1 to see like a different approach. And like, again, what we're looking for is basically an angle for sine that will give us 1. Okay, so which angle is that? And remember that we learned 2 different methods. The unit circle for the multiples of 90, that means 90, 180, 270, 360, and whatnot. And we learned a different method with triangles for 30, 60, and 45 degrees, and the multiples of those angles. So how do I get this one? If you remember, when we talk about the inverse the functions, we talk about the circular functions. We talk about the unit circle, and what we learned was that I can evaluate the multiples of 90, right? 180 and the ones that I just mentioned, and we have like for the first terminal point, we had like 1 and 0. For this one, we had 0, 1. And for this one, we had, those are called terminal points, if you remember, -1, 2. And in here, we got like 0 and -1. Okay. And if you remember too, when we defined the function for sine, we said, hey, sine of a value is going to be equal to y. Cosine, if you remember, it's going to be equal to x. So I'm looking for the y coordinate to find the value. And what I need to find here is, hey, what angle will give me 1 as y? Okay, so if you think on the 0 degrees or 0 radians angle, your value for y is 0, so that's not the one. If you move here, right, you're talking about 90 degrees, and your value it's going to be 1 for y. So in between negative pi over 2 and pi over 2, then you just found your value, the one that works, right? You just find the one that works, because the angle that will make sine to be equal to 1 is going to be 90 degrees. So sine of 90 degrees is going to be equal to 1. So your solution for this guy, because this is actually the problem, will be equal to pi over 2, right? Because that's 90 degrees. So my solution will be pi over 2. Let's do something different. Let's do another problem. Okay, let's do another problem. Let's do I don't know, inverse sine of negative square root of 3 over 2. All right, how are we going to deal with this? Immediately, when you see the square root of 3, you go back to, well, before going ahead, you know that we're looking for an angle for sine that is going to be equal to negative square root of 3 over 2. Okay, so immediately you notice that you have the square root of 3. So we have 60, 30. This is 1, 2, square root of 3. And you notice that sine, it's opposite, again, opposite over hypotenuse. And the one that relates the square root of 3 over 2 will be 60 degrees, right? Because 60 degrees opposite will be the square root of 3. Sine of 60 degrees will be equal to the square root of 3 over hypotenuse, that is 2. But this is halfway because we're looking for a negative. So let's analyze it on the coordinate plane. Remember, the sign for the function is all students take calculus. And you know that sine, it's negative just here, tangent and cosine, right? Just there, in those two quadrants. So to get negative, I need an angle that goes into these two quadrants. And you know that if you just draw an angle here, and you said that this is negative 60 degrees, or negative pi over 3, you know that the sign of sine is going to be negative. So when you evaluate sine of negative 60 degrees, you will get negative square root of 3 over 2. So your answer for inverse sine of negative square root of 3 over 2 will be negative. It will be negative pi over 3, right? Remember that you need to have like a strong knowledge related to how to evaluate functions using triangles, using the unit circle, and using the method that we learned, okay? Let's do a couple with cosine. Let's do something with cosine maybe. For cosine, let's try to define the inverse function first. For cosine, if we have, right, let's do the graph. So we have this, right? You know that this is pi over 2, and you know that this is pi and 3 pi over 2 and 2 pi and whatever. And this is going to be negative pi over 2. And this is going to be negative pi. Okay, that's the graph. Okay, whoops. All right, so the graph for cosine will be something like this, right? You probably remember. It will be something like this, right? This is the graph of cosine, okay? If we try to apply the horizontal line test and we do this, we immediately notice that I'm touching 2 points, right here and right here, okay? And then the function is not one-to-one. How can we make it one-to-one? Well, pretty similar to what we did with sine, we just need to choose these two, right? From here to here, if I erase everything else that I draw, oops. Okay, if we erase that, then we know that we have from 0 to pi, right? We have a function that it's a one-to-one function, so we can define we can define the inverse cosine. Okay, how can we define it? We can define it pretty similar to what we did with sine. Y will be equal to inverse cosine of x if and only if, right? If and only if x is equal to cosine of y. And this happens for a -1 x till 1 and from 0 to pi. Understood? All right. So, okay, so let's do a couple problems related to this. Let's erase all this. And let's erase this because we have clear the domain, the restrictions, all right, and we have the definition. All right, what if we try to evaluate? What if we try to evaluate cosine inverse cosine of 1/2? Okay, same thing. If we go back to the triangle, because we already identify, right? I'm relating 1 and 2, and the triangle that helps me relate 1 and 2 will be 60, 30, and this is 1, this is 2, and this is square root of 3. Which angle will relate? And remember that we're looking, basically, we're looking for cosine of an angle that will give me 1/2. Which angle will relate 1 and 2? Well, cosine, it's adjacent over hypotenuse. And adjacent here is 1. So 1 over hypotenuse, that is 2. Okay, so for 60 degrees, I can have this. So the angle that in radians that allows me to get 1/2 for cosine will be pi over 3. Pi over 3, right? That's the idea to evaluate this type of functions. Okay, let's do another one. What if we try to evaluate cosine of square root of 2/2? Okay. Again, who relates inverse cosine? Inverse cosine. Who relates this? Who relates square root of 2/2? If you remember, we have a triangle that is called the 45, 90, 45, or 45, 45, 90 degrees triangle. And in that triangle, these two sides are the same, and the hypotenuse square root of 2. And remember that when we evaluate cosine of 45 degrees, we say, all right, so adjacent, that is 1, over hypotenuse, that is square root of 2. And that can be rewritten as square root of 2 over 2. So the angle that allows me to get square root of 2/2 is this. This is theta. So this is the angle for inverse cosine of square root of 2/2. So pi over 4, right? Because 45 degrees, pi over 4. Let's do another one. Let's do, what if we try to find, I don't know, let's do a negative. Let's do a negative. So negative square root of 3/2, the one that we did with sine. Or, well, yeah, we can do this one. All right. Who relates square root of 3/2? So if we do the triangle, this is 1. Well, if this is 60, and this is a 30, this is a square. This is 2, this is square root of 3. Who relates square root of 3 and 2? In adjacent, because that's cosine adjacent over hypotenuse. Remember, we're looking for an angle for cosine that will give us square root of 3/2. Negative square root of 3/2. So adjacent is going to be 30 degrees, because adjacent will be square root of 3/2. So we know that it's related to 30 degrees. But we need to have it as a negative. Let's do the analysis to know where it comes from. So we know that the signs of the functions are all students take calculus. So I know that cosine it's negative right here. Cosine is negative right here. Okay. So if I draw an angle from here to here, right, from the first quadrant to the third quadrant, and then I have more than 180 degrees or more than pi. Remember that our domain was restricted, right? We can go from 0 to pi and that's it. And so I cannot go to this quadrant, but I can go to this one, right? I can go to this quadrant, right? So my reference angle for this angle that I just draw here needs to be 30 degrees. 30 degrees. So what will be my angle here? My angle here will be 150 degrees, right? If I'm talking about degrees. If I'm talking, since I know that my answer must be in radians, you know that this 30 degrees, my bad, this 30 degrees is actually pi over 6, right? And if you're dividing the whole thing up here in 6 pieces and you're taking one, you're left with 5. So 5 pi over 6. So which one is the angle that will give me, evaluated on cosine, that will give me negative square root of 3 over 2 will be 5 pi over 6. So it will be 5 pi over 6, right? That will be the angle that works for me trying to evaluate the inverse cosine of negative square root of 3 over 2. Right, that's how you evaluate then these functions. I don't have time to maybe talk about tangent anymore, but I hope that this will help with sine and cosine.